Hey folks, Segasonicfan here, and today I want to talk about a circuit that really everybody should be talking about who uses an Arduino, but for some reason this gets glossed over or it gets called something else. It's all very odd to me, but in electronics, one of the most useful common circuits you can ever have is what's called a latching circuit and a debouncing circuit. A debouncing circuit makes a button press reliable because when you press a button, there's always a little bit of extra noise. There's plenty of videos you can look up about how debouncing works and why it's necessary. I won't go into that, but I will say that debouncing is very useful. It's an annoying problem of physics that can be fixed with a microcontroller or with a 7-4 logic circuit, such as a Schmitt trigger. And the other thing that is super important and super useful all the time is a latching circuit, which is essentially just holding a state, either on or off. Now, why are those useful? Well, those are used in just about anything you ever use that's electronics. Anytime you press a button to turn something on or off, you're using a debounce circuit and you're using a latch circuit. So to me, it's very strange that this is not absolutely all over the place for beginners learning Arduino and learning microcontrollers. As a person who works with 7-4 Boolean logic normally, this is a little bit of a new territory for me. I'm still very new to programming. So the information in this video, take it with a grain of salt. I'm going to try to stick to the facts that I've learned, but I'm still new to it. And I wanted to learn how to do these circuits with a microcontroller. I do them all the time with 7-4 logic, which has its advantages. If you do it with 7-4 logic, it costs much less, uses much less power usually, and it's just more, it can be more efficient in a couple ways, but I won't go into all the details there. Point is, a latch circuit and a demount circuit are really nice. Let's see what that means in reality. I'm going to press this button, and you'll see that LED stays on. It's latched. Press it again, it's off. And because it's debounced, the presses are very, very reliable, as you can see. I can tap them all over the place, and it corresponds really well. So very simple circuit, very useful circuit. Hopefully people find this video useful. So it's a great circuit for absolute beginners, which means people like me basically, into the world of programming. Now this is an Arduino, a little bit of background before we start. This is an Arduino Nano. This has an Atmel 328 microcontroller. The Arduino is just the name of like the software kind of branding stuff. But the microcontroller is what's really important here. The software is Arduino. I mean, I guess it's important too. But these are very cheap because they're not official Arduino products. And so they use, this is the USB transcoder, I believe, that takes the programming bus that this Atmel chip uses and translates it to USB serial data. That's that chip right there. Now that chip, because it's not an official chip, it's not the official chip used in the official Arduino Nano, it can be a little tricky sometimes to get that working. However, if you go on the internets and you search CH340 drivers, you'll come up with this nice tutorial on SparkFun, and then you can go and here it is right here. CH34X, install for Windows. You go here, and WinRAR is going to ask me to spend money. I'm going to say no thank you. And you can install it through that application. That's pretty easy. Now, once that's installed, open your Arduino software and go down here. And once it's installed, you should be able to plug this guy in, and your PC will recognize it. I'm using PC, obviously with Mac people, it's different, but your hardware will actually recognize it, and you'll get a notification when it's plugged in. Here, I'll just go ahead and unplug mine to give you a real beginner tutorial here. So it makes its little plug and play sound. It might not do it because it was already installed the driver, but anyway, once it's installed, the way you know that it's installed correctly, you can open up Device Manager and look at it, but the easiest way is when you open up the Arduino software, if there's a COM port in COM6, like if there's no COM port that you can select, well, that lets you know that your computer is not actually talking to your Arduino board, whatever it is. So my case it is, because I got the driver installed. That's the first thing you want to do. Then you go over to Arduino, what type of Arduino it is. This is a Nano. This is what they call this, the very small board that has the Atmega 328. Atmega 328, which is probably be selected by default. That's what we're using. And then COM6, which is the port. And the programmer, I find with this older board, the MK2 programmer seems to work a little better, but maybe the other one's fine. I don't know. Once we have everything all set up, though, we do have to change a couple things. So I took the original Debounce code and just made a couple of small changes. And I'll explain those right now. So the button pin was originally 2. I changed it to 3 just because it was more convenient for soldering to the board. A lot of you are going to be using breadboards, so whatever. But these are just the digital, these are the digital outputs, and you can, or inputs and outputs, they're I/O pins. You can make these whatever you want. And so those correspond, let me show you in real life, to the, let's get some more lighting over here actually. So in the physical world here, you'll see, if I can get this, sorry for the super shaky camera here, but you'll see here that, it'll get to focus here. You see here it says A1, A2, A3, A4, A5, A6, A7. Those are all analog inputs. And then over here, it's D, you can see D2 there, ground, D2, D3, D4, D5, D6. Those are all digital I/O pins. So D3, which is what this button is soldered to, is 3 there. And they don't call it D3, but when they say 3, they mean digital. And for the LED, I have that with D9. You do need a resistor, of course, current limiting resistor, so you don't blow up your LED. And that's to pin 9. This was originally 13. My board doesn't have a 13. It's a Nano, so I had to change that as well. Now, the big thing that you really got to change, which is very important, and I will say this is the part, this is a part of working with programmer code that really kind of bugs me sometimes, is you come across code that doesn't correspond very well with reality of how PCBs are designed. And you'll notice here it says push button is from 2 to 5 volts. Now, this is designed so that when you press a button, you're actually connecting it to a power rail. That almost never happens in PCB design. That's super rare. Usually when you press a button, it shorts it to ground. Ground is the common, and that's just the safer and far easier way to design a circuit than to have it short to a power rail. So this connecting it to 5 volts makes no sense. Whoever wrote this code has obviously barely looked at a circuit board in their life, which is scary to me because this is an original sketch that comes with Arduino. It was produced in 2006, 2011, and 2012, and yet nobody's changed that part of the code. That's very odd to me, and it speaks to the divide between programmers and electrical engineers and how we have a completely different set of knowledge that is oftentimes not shared and connect those dots, which is what I'm hoping this video will help do today. So the way we change that, fortunately, is quite simple. The last button state here starts out as low, and all we do is we change this to high. That's because the button is connected through our pull-up resistor to 5 volts. And so that means the button it's always high, and then when you press it, it goes low. So last button state, which is initialized, it's basically the initial button state, is going to be high, and then you're triggering a low signal. The rest of the code, I'm still too much of a newbie to understand that much of it. There is a delay. I know about the delay time. This is in milliseconds of how much delay there is between the button press and when it's reading back the data of the signal change. And that has to do, that's how the debounce works, is the noise, like 50 milliseconds is the time it waits for the noise to go away essentially before it takes a reading. And other than that, we have digital write, which I believe this is the library which helps us get our latch, basically keeps the LED on or keeps it off. Pin mode, this is defining if these pins are input or output. Our button pin, which is named, it's just a name, an arbitrary name that was set up here. Constant int button pin equals 3. That's just what we called our button pin. So our button pin is an input. Of course, it's a button. And then our LED pin is an output. Of course, I'm trying to output to an LED. It makes perfect sense. And this part of the code, which I need to read and get more familiar with, I won't go into because I'm not an expert on this stuff, like I was saying. But yeah, you just go, after you're done with that, you go and you can verify your code if you want, and then you can upload it to your, whatever you're using. In this case, it's an Arduino Nano. And if everything's groovy, you will get, you won't get an error. When the text down there is like this orangish red, that's when you know you're in trouble. But if you get something like this, done uploading, then, it's done uploading. You were successful. And what do you know? You got a latching push button. Now, this is super useful in so many applications, and I'm going to show you why I did this right now. The application I'm going to immediately use this for. Keep in mind, this entire board costs about $3. So even though you could do this a lot more inexpensively with a Boolean logic setup, it's not really, it's kind of Boolean logic. I guess it is. If you use 7/4 logic to do this, it requires a little bit more work as far as a circuit design. There's pros and cons, but for $3, and these are super readily available, I'm not going to quibble too much about it. But I have here this very, very abused poor radio here. This is a CCRadio Plus by Sangjian. I've made a video about this on YouTube already, and it's been quite popular. Many hundreds of views. I think it has over 1,000 views now, about how to fix the display on this. And why do people care about this old-ass radio? Well, it's from 2003, and it's actually a pretty awesome piece of electronics. It doesn't look like it right now, but you have a nice LED lamp output, which actually is just basically tied to the 12-volt level. You have this nice charging input if you want to use nickel metal hydride batteries. You have an external antenna, and ground there, you have a nice old-school telescoping antenna here. And it just, the dial is really well designed. Everything has very nice analog feeling controls. I can't give a good example of that when this is all in pieces right now. But it's got inputs and outputs and a recording input as well. It's really useful for recording radio, for hooking it up to a hi-fi system. It's just a nice system. I really do like it, and it really hits the sweet spot for me as far as radios go. So enough about that. I've done some repairs and some hacks to this poor thing. This thing has had a hard life. It had a hard life before I even got it out of the e-waste. And one thing I've done is I've taken the 12-volt rail and turned it into a 5-volt rail through this 7805 regulator. And if we take this, you might ask why I'm doing that. Well, I'm doing that because this thing was originally really badly damaged, and it destroyed the LEDs, the backlight. So actually everything on this works currently. I repaired everything else, but the backlight does not work. Not only that, but the backlight stays on if you have it plugged in. You can't turn it off. Well, I wanted an option to where I could press a button and turn the backlight off. Now there is a button for that. It's this button right here, and it corresponds to the front panel. If you press that button, you can turn the backlight on and off, but only if the unit's using battery. So that's kind of annoying. I would like that button to turn the LED backlight on or off whenever I choose. And I need to install new LEDs. And I need, a good power source for the LEDs. So in comes my latching circuit. I can use this. I can put this pretty much anywhere. I might just put it right there. That's pretty convenient. You'll see I already disconnected the trace to the button once, but I'm going to go ahead and remove that patch that I did so that this button right here will be totally electrically isolated. There's just ground right there. And then I have here, this is actually an N-channel MOSFET that I soldered in there. Let's see if I can zoom in and give you a better shot of this whole thing. That's an N-channel MOSFET which I can use to switch the power to the LEDs depending. I think a Nano will this Atmel Atmega 328 would probably drive the two LEDs I have just fine, but I could use the NFET just to be on the safe side. And so yeah, this button where it is now is actually just going to be wired to that button, and then this LED where it is now, I could wire it to the pins here and here to the two LEDs of the display, or I can use this NFET to drive the LEDs a little bit better. And then I can use the 5 volts from that regulator that I showed you on the top. This is the 5-volt wire, and just solder that here. If I want to do if this was for a customer or something, I would do a much nicer job. I'd include a pluggable harness for that connection as well. But this is an old radio. I'm just getting it going. It's going to sit here next to my workstation, and I just like to play tunes when I'm soldering and doing repairs and builds for you guys. So this is going to be now an additional microcontroller just for a button press, which is kind of strange, but if it works, if it ain't broke, don't fix it. If it works, it works, and it's a good way to learn about Arduino boards and their usefulness in applications for very, very simple examples. So hopefully this video is useful. I know I went kind of fast, but there's so many videos on Arduino stuff, especially on YouTube, all over the internet. And I just wanted to talk specifically about latching and debouncing, how you can combine them very simply to a very simple piece of code and get a button press going. I might make a part 2 to this. Feel free to look on my channel if I made a part 2 to this to show you it actually in action once I install this. But yeah, the big takeaway from this is that programmers out there, please stop making button presses active high. That's really weird. Button presses are always active low, including on this board here. This is an active low signal that it generates the button press. So button presses are always active low. You'll have to change the code for that, unfortunately, because these programmers don't know. And aside from that, though, the code was not needed to change too much. You had to find that special driver, that CH340 driver, do a couple things to set up your Arduino programming environment, as they call it. And you could use breadboard. I just like soldering things on if it's real simple like this. And have fun. Use this to do any number of applications that part of the code where you put in the milliseconds, you can change that to make it so you hold down the button and different stuff for triggering the latch as well. You might need to change some other things to do that. But anyway, it's a good way to start. I'm probably overly complicating this video. Forgive me. I'm new to Arduino, and it's not my forte of things to talk about. But I hope you found some of this useful. As usual, I don't care if you like. I don't care if you subscribe. I make these videos to support the community, and the community has supported me so much over the years. So I hope you enjoy this. I hope you learned something from it. Feel free to let me know if you did or did not. It's cool just to chat with people. You can also check out my website for the circuits that I design and have for sale, as well as news and repair projects I've done, all sorts of different cool stuff. And that is segasonicfan.wixsite.com/retro. It's also in the top of the page here. And have fun hacking and repairing things. Segasonic Fan, signing out.